because to exploit the inherent cohesion between these two, because they two are related. And instance when we create of a class is known as a object. Okay, in C, if we create a structure that consists only of data variables, and if we create instance of that, we call it as a structure variable. But in C++, we'll call it as, say, if I have so if we write here a1, so in C, if we call it as a variable, and this we call it as the structure, I mean the structure name or the structure data type. In C++, the first thing is we'll have an enhanced version of a structure where, say, this is XX, and it will have the capability to encapsulate these two, and maybe here there is some other function, say f1 and f2. So this f1 is somehow related to this particular structure or operating on these structure variables. So in C++, we'll have the ability, or it supports, that we can include the definition of that function or method within it, right? So here you have got, so these are those characteristics, or we can say attributes, and these are the behaviors. There can be many more functions that can be listed one after the other like this. And in this case, again, f2, if it is not related, that remains outside the structure definition as it is. Okay, so this is the C++ way, and this is the C way. And as you can see that this is a limitation which we have overcome here, and this ability to put together both of this is known as, what is this? To have the variables as well as the behaviors or the functions. This is known as technically
encapsulation.
Encapsulation. So are you getting me, all the other students?
Yes, sir.
Yes, sir.
Yes, sir.
And
Yes, sir.
And so these sometimes it is known as attributes, characteristics, and all this. And now if I something like this, if I would like to create instances, it is as simple as this. So again, you write XX, and here you write A1, here you write A2. Now once I write this, I prefer to call them as objects rather than variables, and I prefer to call it, instead of structure, I prefer to call it as a class. XX is a class because it's a class definition. Okay, so but this, either I can call it as a structure or class, doesn't really matter. But in terms of object-oriented terminology, we prefer to call it as a class rather than a structure, because, or you can say it's a enhanced structure. That is how it was designed. The designer, that's why it is C++. So to have compatibility with those who know C, it was designed like that. So in C++, is it a structure? Is it a class definition? Can we call it as a class definition? This one?
Yes, sir.
Can we call it as a class definition?
Yes, sir.
This is the same. The only thing is, Here, instead of structure, you can always write the keyword class. So either you write class or structure, it is almost the same. There is a subtle difference. We'll talk about it later on. Are you getting my point?
Yes, sir.
Yes, sir.
Yes, sir.
So you can say that C++ it has enhanced the way we think about structures, where it can accommodate not only attributes or multiple types of data variables, but along with that a list of variable behaviors or functions which are associated with it. It is more a cohesive unit. And when you now you say that, as I mentioned, like if this particular class, this is a maybe a parent class or whatever you say, it's a base class. Now if you find something like A and B, these are inherited from this. This is inheritance, right? These are we found in the previous design. So if it is the case, now when you are trying to define what? Define this structure A, or say this class A. So what you can do, because it is inherited from this, you can probably borrow the definition from here. You can get it here and you can try to add something more to it, right? Or remove something from out of it. So the thing is, here in this case, you are using not only the structure definition, but you are using this as a unit as a whole. So that is, the reusability is much more. It is much more, mm, intuitive in terms of the real world modeling. So that's why this design or the way of thinking, this philosophy is more appealing to for the design of real world problems or solving real world problems. Got it? So from now onwards, instead of calling a structure, I mean a conventional structure a structure, you better call it as a class. And instead of calling variables, any instance of a class that we create, we call it as an object. In fact, when we write something like this, int x and y, what do we say? What is int?
Int data
Right?
type.
Data type.
Yeah,
Data
data
type.
type, but it is a integer class. So it's a data type, but it actually corresponds to the, or it provides a definition of an integer class of
Class.
objects. So integer class, and then what is this x and y?
Objects of
Objects.
class.
These are
Objects.
objects of that integer class. So we no longer call it as a, yeah. So data type is a more generic term. So data type means, uh, I think you have heard about abstract data type, right?
Yes, sir.
What is abstract data type? So stack is abstract. So abstract data type, in the definition of abstract data type, you have to specify not only the data structures, but also the associated behaviors or the methods, right? So in that sense, you can say that class is actually, it can, in a direct way, it can implement an abstract data type. So from now onwards, we keep using these terminologies instead of calling variables or structures and all this. So can anybody tell me the difference between using the keyword structure and class? If I use the keyword class and if I use the keyword structure, what is the basic difference?
So in
So
class we
In
can
in
structure
define the
only
structure,
data
functions,
by
types and
and
the
in
default
data.
is
structure
public.
only data type can be described.
One at a time.
So in structure only data types can be described. In classes we can define their attributes as well.
No, it's not that. As you can see here, it's a C++ structure. Can you see this? It's a C++ structure. And even though I write structure, I can include both of them. Are you getting my point? I've included both of them here. You see, it's a C++ structure.
So in structure, by default everything is public, and in class by default everything is private.
Yes, that's the only difference. Others, can you follow what he says? These are all will be discussed, so no need to worry about. Just I asked it. Those who know, they can answer. Okay, so the only difference is, so in C++, if you just write struct and you write struct and you try to write the code, run the code, everything will be fine. But the only thing is, you have to keep in mind, we talked about access specifiers. What are access specifiers? What do they specify?
So there are certain keywords that specify the access points for any data type or methods that
A
we are
simple things, as I
defining.
mentioned, that you have got a laptop, you have got some books and Xerox materials. Now you should tag them as private, public, protected, or something like that, right? So that is essential. And in fact, but do we use any kind of access specifiers here? Do we mention any of those keywords here? No. So if you do not mention anything, in case of structure, the default will be
Private. Public.
default will be public, because in C there was no such demarcation, right? So in C, if you write something here, so anybody can access it. So to make it compatible with the notion of a C programmer, if you write here structure, so anything that you put it here, it will be accessible from anybody from outside. Okay, so it is by default. So it is something like if you are in a say in a hostel room which accommodates uh, say more than one student. So if it is not a private room kind of thing, if it is a shared room, that means whatever you say, it will be a public. So it's something like that. So the default is public. So if I want to make these two private, in this case, what I have to do? I have to explicitly write here private. So I just put that keyword and put a colon here. Is that okay? So in C++, if I write the keyword structure, then the default is public. But if I want to really make them private, but still I am using the struct keyword, so I should explicitly write here private. That's all. Is that fine?
Yes, sir.
Yes, sir.
And for class, the default is private. So it's just like if you are having a single room, then everything that you are having, it will be by default, it will be considered to be your private property. So whatever your possessions you are having, so nobody is supposed to touch it or use it. So it is something like that. But still, even though you are staying in a private room, or you have your own room, hostel room, single accommodation room, you may say that, okay, these say maybe my notes that have xeroxed and all this, any of my friend can use it, like that. So you have the flexibility. So being structured, so I can make it this part private, this part public. That means, so these data items, these data variables or data structures are private, but this method is public. Anybody can access this method. It can be vice versa. So if you explicitly tag your attributes or behavior as public or private, then it hardly matters whether you are using here the keyword struct or class. Is that okay?
Yes, sir.
So if you always explicitly mention it, that okay, this is private, this is public, if you are always, so you don't rely on default things, you explicitly mention it. So in that case, either you write it struct or class, it hardly matters. So even though you are writing here struct, but people will know that it's a C++ code. So you are basically coming up with a class definition. However, you are using the struct keyword, that's fine. That's not a problem. Okay. So everything else remains same. So I can just remove this, strike it off and write here class, the whole thing, the entire program works. Okay. Is that fine?
Yes, sir.
Yes, sir.
Yes, sir.
So we'll see
Yes,
the
sir.
syntax in details, but this just to give some idea. And then we have talked about composition, inheritance and all this. So there are few more additional benefits or features which also mimics the real world experiences. One of them is like if I talk in terms of C++ terminology or C terminology. So see what happens. If you are say I would like to write a three functions. One is sum that accepts one argument. Sorry, that accepts two arguments, 3 and 5. And then another function sum that accepts just one argument, but if there is one argument, it will just add it with 0. Two arguments means it will add these two elements, and the three arguments means it will add 3, 5, and 9, like this. So my objective is to write three functions in C that will accept one of them will accept one argument, one will two arguments, and three arguments, and they will basically add perform the sum of these two. In this particular case, it will add it with 0. So will these be supported in C? I would like to have
No,
three
sir.
functions.
No, sir.
What is the problem? What is the basic requirement in C? The function names should be
Different.
unique, right?
Yes.
So these function names that's the requirement, right? So how to make the changes? So you can, if that is the case, you can call it as sum1, you can call it as sum2, you can call it as sum3. Now the function names are distinguishable and this will be allowed, right?
Yes.
Yes, sir.
But in C++, if you look into C++, this is allowed. Does it look strange?
Yes.
Yes, sir.
So function names may not be unique. May not. Generally they will be unique, but may not. Why are these not unique? In my sense, I say that okay, they are all performing logically the same operation. They are trying to add something. So then sum1, sum2, sum3. Why should I do that? Why don't I will have the flexibility just like this? So if I allow this, whose benefit is it for? Who gets benefited? What is the problem here? If I force you to write unique names, what is your problem? And
We
if I
have to
allow you
write
to write
many different functions.
Yes.
hmm?
Multiple
What is that?
multiple functions.
No, my point is if I allow you that the function names may not be unique, so whose benefit is it is meant for? Who gets benefited?
The
Compiler,
programmer.
the programmer. Who gets benefited? The programmer. Or in other words, if I read your code, right? So if I'm using your code, if I'm using your functions that you have written, I don't have to recall three different function names. These are pretty simple, but there may be some. So if you have got 10 such functions which are having more or less similar logical activity, but they just differ on the number of arguments that they accept and their types. So there is difference in the types and the number of arguments, but logically the algorithm is more or less the same. So you don't have to take the burden of recalling all those distinct function names in this case. Do you accept that?
Yes, sir.
Yes. Yes.
So that's a big advantage. And in fact, you always find that. I mean, say something like matrix multiplication. So matrix multiplication, if it is or maybe say matrix read. So if it is a matrix read, so depending on the elements, if it is an integer matrix, so you have to write matrix read, integer matrix read, then character matrix read, then float matrix. So the thing is, their all purpose is to read the elements and put them in that 2D array of that matrix, or the 2D say arrangement. But you have to write separate functions because the data type differs. That's the only thing. and then recalling all them is a burden. So the C++ allows you to have the same name given for all. Now, how do you think? So that ease of recalling or ease of remembering from the programmer's perspective, or if I read your code, I'll be easy to follow. I know that they are all having the same purpose with a slight bit of difference in the number of arguments and type. So how do you think it will be resolved? Like in your class, if you have got, say, there are two Akshay. So maybe Akshay Sharma. There are two students having the same names, Akshay Sharma. It might happen, right? So as a faculty, so for so for those, so it's not a benefit. So for a faculty who wants to recall who is which person, so how do I resolve it? Or what do you think, how the compiler resolves it? So if you make a call something like this, some if you write here say 6,12. So if you have got the different bodies, so how do you know that which particular body need to be called? Because the
By
definitions will
looking at
have all the same names, right? So how the compiler binds to the particular body, how it differentiates?
Based on arguments.
The number of
Number
arguments.
Number of inputs.
So number of
By
inputs,
checking
that
the
is fine,
number.
but do you know what goes in the back of it? So the thing is here,
Based on number of inputs and the data type of the input.
Multiple constructor
so
is
that
used
actually
there,
what
so
happens, this particular name gets translated to something like this. Just a minute. So this gets translated to something like this. Can you see the translation?
yes, sir.
This gets translated to something like this. And this gets translated to something like, are you getting my point? Can you see the difference?
Yes, sir.
So internally, because nothing is done automatic, so it seems to be a magic, right? Because no matter what you are calling it, the compiler knows intelligently that which particular function body, because there should be three function bodies, that is for sure. Three function definitions that need to be preserved, or that need to be stored. Now whenever you are calling from the main some of the this sum, so which particular sum you are actually hinting at, so that need to be resolved. So for that, uh, internally, once you write this, but during compilation the compiler translates these names to something like this, so that it can now you know that, but the internally the compiler knows that you are actually having some int, some int, and some int. So uh, in the back end, the compiler knows that it is having distinct functions, and there is no problem in binding them whenever you are calling it. So whenever you are calling it also, it will be translated to this nomenclature. So what is the actual translation scheme that it follows, that depends on the compiler, but something like this happens. So once it is there, now you see there is no difference between the C and C++, because it has actually internally translated it automatically without letting you know that something has been done. So it becomes more user friendly, but there is some burden that is taken by the compiler during the compilation. Is that fine?
Yes, sir.
Yes, sir.
So this feature of allowing the same function names to be used for multiple functions having the similar logic, what is this called?
Function
Those-
overloading.
Method overloading.
function overloading.
This is called function overloading. Okay, those who do not know, no need to worry about. This is called function function overloading. The term function is fine, it is intuitive, but why it is called overloading? What is called overloading?
So because using the same name, we are giving three different methods.
Yes. So the thing is, say, if I say that my name is SN, say, see, I am SN. Now the SN, what I do, I am a part of the administration because for these 2 years I'm playing the role of HOD. So I am a part of the administration, but above all, I am a faculty. And maybe I have enrolled in some online courses, so I'm a student also in that sense. So the same person, it has got different roles to play depending on the context. So when I'm doing that class in the online course, I'm a student. When I'm in my office, HOD's room, specific for the HOD's room, then so my role completely gets changed. And when I'm uh, sitting in my own office, then I'm just a normal faculty, right? So the same person behaves differently in different context. So I say that, okay, I'm too much overloaded, so I have to do this and all this. So the overload term is pretty commonly used in a real scenario also, and here also that's the same thing. So the same function name sum uh, is overloaded to execute different logic. So it has got a different logic, it has got a different logic, it's got a different logic. So the body of the functions are different, but just by using the same name you can call them, and the differentiation is done by the compiler internally without uh, the programmer need to bother about how it is done. So this is overloading, and this is something new, completely new in C++ or in any object-oriented language. So C++ provides, Java provides, Python provides. So all the object-oriented languages provide this feature. So there is another kind of interesting, say, feature. Say, for example, if I write here intx uh, equals to 5, and then x and y, and then I write int z equals to x plus y. So what is this? So this is the addition operator. If I write here for character, will it work? So this still addition operator. Will it work for characters also?
No, sir.
Hmm?
So their ASCII
And
code
it is-
will be added and then converted into character.
Yeah, so they will. So it will work in some sense. It will work. But if I write something like, it will work for float also, right? Float,
Yes.
it will work. But if I write something like this, string, will it work?
Yes, sir.
Yes, sir.
Yes, sir.
If it is a C, so in C++,
Yes,
interestingly, there is a string class. So string class, is it there in C? No. So in C++, there is a string class, and you can have this flexibility, right? And so if I have got a linked list class, so you have implemented, and you are writing here L1 equals to L1 plus L2 plus L3, will it work? Here
No,
you
sir.
mean that this L3, this linked list will be added to this L2. So that means this is a linked list, this is a linked list, so this will be concatenated to this. This is what you want, right? So will it be done here?
No, sir.
We have to implement that.
Yes. So the
No,
thing
sir.
is, will it be done? So the thing is,
We have to define something in the linked list
yes.
class.
So this is automatically done. This is automatically done. This is also automatically done, right? So these are automatic. So even if you don't write anything, it will work. Even this also will work. But to make it happen, so this is also possible with some extra effort. With some extra programming effort, you can make it happen. So probably you have already done that. So what this operation is called as in case of linked list?
Concatenation.
Adding one linked list to the other, the end of the other. What is it called?
Concatenation.
Concatenation. So probably earlier you would have preferred to do it something like this, right? So that is how you did it, right?
Yes, sir.
But now you can, once you know, you will be knowing this, once you know how with additional programming effort we can write this. So which one looks better? I mean, which one looks more appealing as uh, a programmer or something who is going to use your codes? You wrote the code and I'm going to use your functions or methods and all this. Which one is more acceptable or readable?
So
First
first
one.
L2 plus.
So first one.
Like that.
This one. So this
L
one seems
plus.
more compact, right? You know that. So L2, L3, even though without specifying anything, you know that this probably, what do I mean? So string means that means this gets, so this is the surname, this may be the first name, this may be the surname, this is the first link, this second link. So this is obvious. So sometimes we can convey something in a more meaningful way, or if we use, so these are operators, right? So these are operators. So using this operator, as you can see, sometimes it is addition, sometimes it may not be addition, but it may be something that is similar to addition. We would like to associate that meaning. Say for example, in case of a complex number, we write C1 equals to C2 plus C3. Complex, does C++ support any class like complex? Do you know? Is there any
No,
class called complex? Which
No, sir.
a class which can store and process uh, complex values, complex numbers?
No, sir.
No, sir.
No, it's not possible. So if I write so if you write a complex class, if you know how to write it, now if you would like to have this feature, so that two complex numbers, if I write plus, it will be added and it will be more readable. So I know that how integers are added and complex numbers are added. So complex number addition means you have to separately add the real part, imaginary part, but that is different thing. That's the logical part. But you know that even for complex numbers also, instead of writing a function, something like writing something like add complex and writing C2 plus C3 and putting in C1, instead of doing this is a better option, right? So we probably don't do this, rather than we prefer this. We probably don't do this, rather than we prefer this. Is that okay?
Yes, sir.
So this is again an additional feature. So what we are trying to do here, whom we are overloading? So whom we are
Operator.
overloading here?
Addition operator.
The addition operator. You see, the addition operator will, so this is the particular thing that gets overloaded. So this one, and what is this? This is addition is an operator. So this is what is called as okay. So there are two additional features that we found that is supported by C++. One is, or maybe object-oriented languages. One is function overloading, another is operator overloading. Is that fine? Now the compiler, so you are using the same addition operator, but if you supply two string operands, it will know that it will be concatenating them. If you supply two characters, it will know that it will be actually adding the ASCII values. If you supply two integers in both sides, it will know that it has to basically perform arithmetic operation. If it is a complex number, it knows that you have to you have to add the real and imaginary separately, like that. So once you are writing this, the compiler will try to know the context, the type. It will test the type of the two arguments because it's a binary operator. So it will check both the argument types, and accordingly it will decide what need to be done. Okay, so this extra programming effort means you have to write some additional methods for doing this, and we'll see that what those methods, how those methods should be, and what should be the names of those methods. Is that fine? So here you have to write
Yes,
a
sir.
special method or special function to make it happen. I mean, to make this or this happen. So we'll see that. So function overloading and operator overloading, this in general, what is this called? Any idea?
Polymorphism.
A and B.
Polymorphism.
So these are, in a combined way, these are called polymorphism. Oh, it's gone completely. What is there? Anyway. Okay, so can you see this now?
Yes, sir.
So this polymorphism is an ability to assign different meaning to a particular symbol. It can be either operator, it can be method, or it can be class, and all this in a different context, right? So here the thing is, as I mentioned, as a person, I act differently or I perform different activities depending on the context. As I mean, the same person, if I am sitting in my office, in my normal office, I'll be behaving like a normal faculty. When I sit in the HOD's chamber, so I'll behave like an administrator. So try to follow those protocols. When I am maybe I'm attending some class or some workshop, I will be behaving like a student. So it is entirely dependent on the context. Same in this case, operator can be overloaded, and there are many such examples. So I mean, this plus operator, you see that it is already overloaded. Even in C also, you can say that this is overloaded because plus can work for adding floats, characters, integers, and all this. So you can say that, okay, overloading, operator overloading to some extent is always there. But what is not there is if I would like to write complex C1 equals to C1 plus C2, that is not supported in C. Okay, so overloading feature is there, but you cannot extend the feature for new data types that you design in C. Is that part clear?
Yes, sir.
Yes, sir.
Yes, sir.
It is already there, so it's nothing new. But the only thing is you cannot extend the feature for new data types like stack, queue, or complex numbers or trees or whatever. So that is not possible. But in C++, will enable you with the feature through which you can extend it to other user-defined classes also. And for that, you just have to write a special function for doing so. And what is that function? Can you just to mention it? We'll get into the details of it later on. For that complex, can you tell me what will be how the function name will look like? Those who know C++, what should I write? What function should I write? So what I'm writing a complex class, right? So in the complex class, so it's class complex. I write too many things, but I have to add one more function to make it possible. What is that function? What is the name of the function? Any idea?
Sir, operator
Hmm.
plus complex C or complex whatever variable we want to give. Bracket, the parenthesis.
Okay, I'm not going into the details of the syntax. So now it will have two arguments. So you say that complex, say x, and complex y. So these are the arguments. So this C2 will be copied here, C1 will be copied to y. But look into this. What is the function name?
Operator.
Operator plus.
Operator plus. Are you getting my point? So you are trying to write some equivalent function which supports this nice feature, this overloading of that operator, this one. So it's an operator. So we call it as operator functions. And then you write the details of adding, the adding of those real parts and imaginary parts. So all this is fine. But in C you don't have this feature. So you don't have the ability to do this. So this operator, so its operator is a keyword. So for overloading minus operator, you have to write operator minus and then write the details. Okay, so what is the exact logic of uh, adding or subtracting, that is up to you. But this feature of readability, enhanced readability, is provided, and all these are known as polymorphism. So before I get into the rest of the topics, let me show you another. So can you see this? Can you see the screen?
Yes, sir.
Yes, sir.
What is this? It's a stack. Can you see it's a stack class stack, right? Can you read this? And can you see what is there? It's a, so we have got the array pointer or a pointer to something, and there is top size and all this. There is n, so there is empty, is full. I think these are all known to you. Then just ignore these things. Then push, pop, and all this. So what is there? So it is a true class, right? It's a true class where you can see that it has truly encapsulated these data members, which are nothing but the characteristics of a stack. What a stack will contain? It will contain a 1D space for storing the elements. It will contain the top index. It will contain the size and all this, and it will also contain some functions or methods to operate on that particular stack, right? That is there. Got it?
So just one thing.
Yes.
So can you
Yes.
explain that line 22 why the not operate that symbol is there?
Yeah, let's ignore it. I'm not focusing it there.
Okay, okay.
So you will not get many things, and those who are new to this C++, many things will be strange. Just forget about this. I'm trying to show something different, and my focus is something different. So yeah, this one you ignore it. This is a destructor, so just ignore it right now. So can you see that we have labeled all of them either public or private? So we have explicitly mentioned it without relying on the default say definitions or default tagging that is there, right? Hello?
Yes, sir.
Yes, sir.
So once you tag it as public, so everything will be public that follows. Once you tag it as private, so both of these two will be treated as private. Now once you have done that, so instead of class, if I write here struct, does it really matter?
No, sir.
No, sir.
No. So it is because you have already made things explicit. But because you are writing a C++ code and it's object-oriented programming, so better you just mention class instead of structure. So to make it in terms of the terminology. So this is one thing. So another thing is, so when you write a stack in C, the first thing is what should be the first question that you ask? Am I supposed to write an integer stack or a float stack or a character stack, right? That is what you ask. And if I don't say anything, probably without asking anything, you write an integer stack program. Am I right?
Yes, sir.
Yes, sir.
And the thing is,
Yes,
the
sir.
next day, if I ask you Okay, why don't you write a floating point stack? What you will do?
We'll change the int
Change
You
with
keep
all
on
the
changing all the
numbers.
int, you keep on changing to make it float. But if I now say that, okay, I would like to have both the integer stack and the float stack, or maybe a character stack simultaneously in your code, then what do you do?
We will then we have to
not
make a new
possible.
structure.
In C,
So
we
what you
have
do
to write.
basically, you copy. So you first write an integer stack, check it if it's working or not. Then you copy the whole code, substitute all the int, you replace it by float. Then you copy it. Again, you replace the float with character like that, and you test it. That is what you do, right?
So hard point.
Yes, sir.
Hmm?
We have to use
Yes,
hard
sir.
pointer.
Yes, sir.
So as you can see from the coding point of view, so you unnecessarily you have to yourself copy and then make the changes. But is there any logical difference between these three pieces of codes, these three stack definitions that you write?
No, sir.
No.
They only differ in the type of arguments or type of the elements that they store. That's all, right?
Yes, sir.
Yes, sir.
But you have to repeat, and you have to have say thrice of the size of the code that it should have, right? So C++ helps you in this aspect also. So as you can see here, again, I'm not going to the syntactic details, but somehow we have implemented it, and the details of the push and pop is here. I've put them. Uh, I've hidden them. So the thing is now, can you see this one? Can you read this and see what is happening?
It is a stack of float and data type,
So
and we are
now,
pushing
so
float.
first of all, how many definitions I have got here? How many definitions? Just one definition, right?
Yes, sir.
I have got just one stack definition. Is that okay? And what is following this is just detailing of these functions, the display, push and pop. I'm just detailing it. So what I am having just one definition of the stack, and now I'm trying to create a floating point stack. If you see, it's a floating point stack just by mentioning something like this within this braces, I mean float. And I say that S1. So S1 is going to be an instance, a floating point stack whose size is at most 5. And then I can, when I push something to S1, it will be all floating point values, right? Now at the same time, I can just use the same definition, and then I instantiate or I create a integer stack S2 just by putting the keyword int here, and which can hold at most 9 integers. In the same way, I can create a character stack by doing this. Can you see this? And which is allowed to push you uh, character elements. Can you see the use of it?
Yes, sir.
Yes, sir.
But how many
Yes, sir.
definitions I have got here in the top?
One.
Just one.
One.
So this is the feature that helps you to just define to give one definition as a template. So template is just like, it's not so it's just an outline. Template, it has got a in the English vocabulary also it has got a meaning. So template is just try to give an idea how it will look like, but it is not the actual definition. So you just create a template. It's a it's a term which is well used. So you give a template. So this class is now becomes a template class, and this template class is just an idea. So once you write this, so the floating point instance of that class is created. So one that you create, that you would have created manually, that gets created right now. Okay, and using that you can create as many as like say a 10. So using that you have created two floating point stacks. One is a, one is s1. Now the same definition, the template definition I'm using to create a integer stack. The same template definition I'm using to create a character stack. So that's what I mean is C++ provides you the different types of polymorphism. This is also a polymorphic feature. Polymorphic means what? Because you have got a template definition which according to your need you can instantiate to either integer type, a float type, a character type, a complex type, or whatever you want. Got it? So polymorphism, you know, so poly means multiple and morph means shape. So the same thing you have got, it works differently in different context. Is that part clear?
Yes, sir.
Yes, sir.
Yes,
And
sir.
that's why I write that it's the ability to assign different meaning to a particular symbol. So the word I use is symbol. And what is a symbol? It can be operator. If it is an operator, I'll be that means I'm talking about operator overloading. If it is a method, I'm calling it as what is the term that I'm associating with?
You like we have a
Function
class.
overloading.
So we have a class actually at 11 a.m.
Okay, you're fine. So it is method means function overloading, and if it is a class that I'm overloading, we call it as a template, like that. Okay. So
Sir,
hmm.
I mean, are all the methods, I mean, memory efficient? I mean, in C, if we write three sum functions, and in C++, if we just function overload, which one will be more memory efficient, or both will perform at the same?
See, in terms of memory, because ultimately at the back end, as I mentioned, you have to, if you are overloading a function in three forms, you have to have three of them. If you are overloading
Yes, sir.
a function in three ways, so in the back end, either you write, that is in C. In this case, the C++ generates three different copies by annotating the names. So in terms of memory, in the back end, both are the same. But you don't have to put, you don't have to take the burden of, you know, writing, creating three copies. That's the point. That is taken care of by the C++ compiler. That's the only thing. Hello? Is that okay? Any
Someone
more
removes.
questions?
Okay, thanks.
Okay, so this is typically a top level view. So there will be many more questions. Those who have studied C++, they might have a different set of questions. Those who have not studied C++ or any object-oriented language, they might have a different set of questions, because every new thing that comes, a new feature that comes, either they are quite surprised or they are quite happy. And they might be sometimes quite critical that why it is required. So like that. But again, each of these features will be explaining in details, knowing the need, how we implement it, what are the other issues related to that. These are top level views. So this object-oriented languages, object-oriented paradigm, this supports polymorphism, encapsulation, then access permissions. uh, so there are so many things, and one thing that I'm skipping in the introductory classes is dynamic binding. I think those who have those who are introduced with virtual functions and all, they know it better. I skip that for the time being. So in the next class, I'll be just talking about the introduction of C++, how it evolved and who invented it, and we will write the very first code of C++, that is temperature conversion. Okay. Anything else? Otherwise, I'll leave.
Thank
Oh,
you,
sir,
sir.
just stop the recording.
Okay. Thank you.
Thank you, sir.